All right, so we're going to talk about reactivity. We talked about this a little bit yesterday. You took a few notes. So none of this stuff should be completely new to you, but I think this will fill in some gaps that you might have in understanding what reactivity is and the role valence electrons play in reactivity. So reactivity. Remember from yesterday that reactivity describes how atoms interact with each other. We determine reactivity by looking at valence electrons. Now, valence electrons, remember, are electrons on the outermost shell of an atom. They move freely when there's less than 8, and they are what make atoms reactive. So please remember that definition. It's going to come up later on in these videos, and you'll see it again, and you'll see it throughout this entire unit. So please remember that valence electrons are electrons on the outermost shell of an atom. They move freely when there's less than 8, and they are what make atoms reactive. If you have not written that down as Cornell notes, please do so now. So this is a lithium atom. We looked at lithium yesterday. You drew it on your notebook. In this lithium atom, this guy is the valence electron. The valence electron is the one on the outside. These things are not valence electrons. Those are regular electrons. We're not interested in those right now. We're only interested in the ones on the outside, the valence electrons. So because lithium only has one valence electron, remember it's trying to get 7 more. It's trying to fill up its shells and get all 8. It wants to get 8 valence electrons total. So we'll do anything it can to get those 8. When lithium reacts with water, you get something like this that happens. It catches on fire and it explodes. It is highly reactive. Everything in that first group in column 1 is very, very reactive and reacts this type of way. Francium and cesium, the ones at the bottom, react very, very violently. They're the ones that are the most reactive. There's a video that I showed you a little while ago of them doing a cesium reaction, and it's pretty violent. So basically what's going on is that the lithium is stealing electrons from the water. It's trying to fill up its outside shell with electrons, so it steals the electrons from the water to fill itself up. As it steals those electrons, a lot of energy is released, and that's what you see in that picture. On the other hand, you have xenon. If you count the valence electrons in xenon, we have 1, 2, 3, 4, 5, 6, 7, 8. We have all 8 valence electrons. Xenon is then not reactive at all. It has all of its valence electrons. It's not looking for any more, and no one can steal from it. So xenon is completely stable. It's over in that last column, in column 8, the noble gases. They are completely stable. It has all 8 valence electrons. Again, these electrons in the middle are not valence electrons. Those are just regular electrons. They're neat, they're useful, but they're not anything we need to worry about. We're only worried about the ones in the outside shell. So let's look at this as an example. This is an analogy for what electrons are, valence electrons are. So think about everything in columns 1 and 2. We'll call this picture 1 and 2. This is columns 1 and 2 of your periodic table. This is a seedy motel. If we use motels as analogies, motels and hotels will do anything to get customers. They're all about pleasing customers. So think about this as a motel that will do anything to get customers. This represents lithium. It's going to do anything it can to get customers. It's kind of a seedy place. Violent things happen there. People live there that will steal your money. Think about the outside valence electron. That one valence electron is the lonely guy at the hotel who'll steal your money, right? This place is not a place that other elements wants to go because they're going to get robbed. The transition metals, the things in the middle, so we'll call this 3 through maybe 6. These are transition metals. It's all right. They can always use more business. So, you know, they'll take your money. They need more customers to live there or to stay there overnight. They'll do what they can, but they're okay. They're not out to rob you. They're not out to get you. They're usually pretty nice places. They're pretty all right. And then you can think of column 7 and 8 as the Omni in Cancun, right? This place is always full. It's Noble Gas. It's fully booked. It's got all of its rooms full. No one is leaving. Very upscale, very stable. Violent bad things don't happen here. It's a very nice place to be. So in column 1 and 2, this guy is a seedy, crappy hotel. Steal from you. This hotel, upscale, pretty great. You don't expect a lot of criminals to be there trying to steal your money. Or, in our case, steal your electrons.